This is Kevin. I'm a software engineer at Google, and Cal Berkeley, Eeks grad, go Bears. And today I'm going to talk about LeetCode number 8, string to integer, A to I, ASCII to integer. Cool. So this problem, basically it's just asking you to convert a number that's in a string into an integer. And the string could have some, could have different things in it. So it's going to have white space. It's going to have a plus or minus symbol, or it may have a plus or minus symbol, and it's going to have some numbers, right? And then it could have some random characters. And it's also going to have, it also should be in between your max int and min int constraints, right? So, yeah. So, okay, cool. So that's not too bad. So, I think, let's see here. So what we can do here basically is, let's start with doing a couple use cases actually. So 42 goes to 42, right? That's what they're saying. You can have some white space in front, and the white space will get deleted and go to 42. The plus minus symbol, right? That's fine. You could have some huge number, and that would actually just be output to max int, which I will go over what that is in a second. And we could also have some characters to start off the word. And if there's any characters, then this will just go to 0. And you can have a number first, then characters, right? And that's actually okay. So that's going to be 13, 12. So that's actually, I'm going to move this up to here. These are the ones that all return some number. These are the ones that are kind of like invalid use cases. You could have white space, a plus symbol, then some characters, then a number, and this would go to 0. Why? Because your plus symbol, your characters, your letters come before the number. So this is just basically what it looked like. Valid. Invalid. All right. So I think, it should be pretty, in terms of the conceptual idea behind this, it's pretty straightforward, right? You start with, checking for white space. You check your symbol, check the numbers. If you don't see any of these, then you may run into some characters. And then if you run into characters without seeing the numbers, then you basically just return 0. So, or you can basically just keep calculating the number until you run into characters. And if you don't see any, you'll start with 0 and you'll end with 0. But if you see some numbers, then you can, increase that number to whatever you see. So that's basically how we're going to go about this. So we're going to start with our result of being 0, and as we run into more characters, we'll add them into this result. We'll also have an index, which is 0, which is what we're going to use to iterate through the string. So the first thing we'll do is check for white space. White space. Okay. And so what is white space? White space is just the space character. So we'll just go ahead and do all string I equals the space character. We'll increment our pointer, right? Does that make sense? Basically, we'll just keep iterating. We'll start from the beginning, or 0 index, keep moving forward until we see a non-white space character. But what if we have, let's say, what if we have a empty string like this, right? That should also return 0. We don't want to increment this if we're already at the end of the string, because we're going to error out. So I must also be less than length string. Just do that first, so make sure we don't kind of reference something off the end. Cool, easy, white space. All right, next, the plus minus symbol. So we can do it a pretty similar way, except that we're only going to see one plus or minus symbol. So we don't really need to do this while loop, right? So we can just say if I is less than string, and your string at I is equal to the minus symbol, then move forward. And we should also track that we have seen the negative symbol. So let's just keep another variable. And we'll say negative equals -1, right? We've seen a negative number. And then also, we could also potentially see a positive symbol, right? So in that case, we'll increment our I again, and we'll say negative equals 1. And we can only see this or this type of symbol, and we'll only see it once. And we could also see no symbol, and if we had no symbol, right, then it would just be a positive number. So we'll set this off at 1. So that would imply that if we didn't enter any of these checks, we would still have a positive number. And then we can just delete this, right? Because if we only see the positive, then it's already positive, so we're good. So this will kind of allow us to check for the symbol. All right, next, let's check for the number. The number needs to be between 0 and 9. So I would like to use a checker, which is going to be all these characters, right? This is the only character that we can encounter. This is just the Python set. It's going to basically break these out into the individual characters. And it's just going to say, like, in constant time, does this checker contain a 0? Does this checker contain a 5? It doesn't need to iterate through the whole thing. It'll return it in constant time. It's very similar to a Python dictionary or a hash map in other languages. Okay? So it's similar to the dictionary, but it does not have a value, so it only has a key, right? It's not a key-value pair. It only has the key. But in terms of the constant time access, it's very similar. All right, so then we'll continue to iterate through the string while we're not at the end of the string. Then we will, if your string, the character is in your checker, then actually, let's go like this. If I is not at the end of the string and your string is in the checker, then we'll basically capture this number, right? So res will become res times 10 plus string at I. And what am I doing here? I'm basically saying, like, let's say you have the number 123. You're basically, and your res is 0. You're going to multiply that by 10, still 0, and then you take your first character, string at I, which is 1, right? Your first one. So this becomes 1. Then you look at this number, 2. So then you multiply res by 10 to get 10, and then you add the 2 in. Then you multiply by 10 again, you add the 3 in. That's how this would work. So we'll just slowly build out the res, our return. The res is short for result. So then we'll increment the index by 1, and that'll basically allow us to capture all the numbers. Okay. And then now we just need to perform our check of the max to min int constraint. So we can just say if, first we should do res equals res times negative, right? So we've captured the symbols. Now we just make sure that we say what it is, and then we can go. If res is less than 0, if it's a negative number, then return the, let's just kind of capture the max int as well. Max int minint 2 to the 31, negative 2 to the 31. So max of res and minint. Otherwise, return min of res and maxint. Right. So basically, if you have a negative number, then we want to return the max, which is the less negative between these two. So if it's 2 negative, we'll return the minint. And for the if it's a positive number, we'll return the lesser of the maxint and that. So it can't go past maxint. Cool. So this is a check the max/min int. So I think this is basically should cover it. So I'm going to go ahead and try submitting this. Oop. Oh, of course. Yeah, just turning. So this string at I is going to be a character, and then I'm just going to transform that into an integer before I add it in. So we're doing all this arithmetic, it has to be all integers. Cool. Looks like it works. So that basically should cover the basic idea. What's space and time complexity of this guy? All right. Time, space. Time complexity is, let's see here. Each of these operations is going to increment the I by 1, essentially, right? And so you basically just do some constant time operation on every character. So it's really just going to be n, where n is the number of characters. Okay. Space, constant space. You basically have these 3 variables that you're changing. You might argue that the result, the res, grows with the input, and that's technically true, but since the result can never grow past your max or min int, then it's actually just going to be captured in a single integer variable, so I would argue that it's actually a constant space. Cool. That's basically it for how this would work in terms of the high-level idea behind it. But one thing in an interview that they might also ask you is, well, there's a kind of a little bit of a strange thing here, is that this res could actually overflow, right? Because what we're doing is we're incrementing the res. So let's say we took this use case of all the 9s. This res would basically become like a number that is all 9s. And then later we would compare it against the min or max int, and we would truncate it down to that value. So actually, let me just show what these are so that it's a little bit easier to conceptualize. All right, so I'll show what these are. So right. So in theory, our numbers in Python, it's not a problem because a number doesn't have a max size that it can go to, but in some languages, I guess that's what they're saying, like, we don't want to overflow past this, right? So this is the biggest number you can store in 32 bits. So if we had an input like this, it's too big. And at some point, our res is going to be this huge thing of all 9s, and it's going to be bigger than this guy, which means that we technically are overflowing by the logic of the code. So in the interview, they don't really care what language you use because they really care about the logic, right? They care about how you think about it. So I guess if you want it to be, fully technically correct, you can also set it up so that this res does not ever overflow past this. So how would you do that? So let's try that out. So if your current res is greater than, so basically you're going to multiply res by 10, and then you're going to add the next number in. So you basically don't want your res to, if your res divided by 10 cannot be, or your res cannot be bigger than your max int over 10, because you're going to multiply by 10. So basically, if your res is this number, and then you multiply it by 10, it becomes this, right? And this is still under the cap. But if any of these numbers is bigger, so let's say this was a 9, you're above your cap. So basically, your res cannot be greater than max int over 10 before you do this next operation. Oops. So that's one part of it. So if that, then we would return something, right? We would just break out of this while loop. Or if your res is equal to max int over 10 and your next character, so basically you'll be at this point and you basically can add up to a 7 if it's positive or up to an 8 if it's negative. So let's just say and int of string at I is greater than 7. We'll basically break out of this and we'll return something. So this just means that our res is, in this situation, our res is about to overflow. I'm only using max int here because the number is always going to be a positive number right now. So basically we would return max int if negative equals 1, right? If it's positive, otherwise we'll return min int. And so does this really work for both of them? Well, let's say this will be captured if you're at this point and then the next character is greater than 7, so 8, 9, or 10. So if it's 8, 9, or 10 in the negative case, that's going to be either your min int or greater than your min int. So those should all return min int, so that's fine. If it's greater than 7, that will capture 8 and 9. So those are both overflow cases. So then returning max int is fine for the positive case as well. And then if it's right at 7, which is the max int, it doesn't actually exit through here, but then your res will basically become the max int, so it doesn't overflow either. And then on the next iteration, if you overflow, it'll be caught by this before it actually overflows. So just having this in here will do the trick. Cool, so I'll just go ahead. And if we have the check here, we no longer need this, right? So then it becomes, so then you basically have your res, which will be below the threshold. If it's, oh, and then one other use case. What if you had this min int situation? Oh, so the min int will actually just exit out here. Right, so that's fine. I was just thinking if this res was a positive version of this and then multiply by -1, and then that would actually, you can't have the positive with the 8 at the end, but it doesn't ever do that. So it's captured by this as well, so you're good. So this would basically be a more correct version, right? Just checking the max min before you increment your res. So I'll go ahead and submit. Just make sure this works. Oh, forgot to return this. All right, so that should do it for this in terms of conceptually how this would work. So, yep, and if you have any questions, any follow-up, feel free to reach out to me. I'll make this smaller so you can see the code. Here's the code. Here's the ideas. I also have a link in the description where you can check out the code directly. Any questions that you want me to clarify or go into more detail, don't hesitate. Leave a comment. I'll make a follow-up video. All right, best of luck with interviews. Thanks so much.